Hi, in this video we'll be talking about the order of arguments. If you haven't watched my video on argument matching modes in Python, you may want to watch it first. As mentioned in the previous videos, there are several types of arguments: positional arguments, keyword arguments, default arguments, star arguments, and double star arguments. I briefly mentioned what order they must be in if there are more than one type passed to a function, but in this video we'll talk about it in more detail. So, if there are both positional and keyword arguments, the positional ones must come first in the function call. Have a look. Now let's call this function func for 5 d equals 1, c equals 6. The function just returns the sum of the arguments. So here we have the two positional arguments, and then we have the two keyword arguments. They must come in this order: first positional ones, then keyword ones. Otherwise, it won't work. Let's try it out. Func c equals 6, d equals 1, 4, 5. So what we're trying to do now is pass the keyword arguments first and the positional arguments next. But this won't work. Positional argument follows keyword argument, which is wrong. By the way, keyword arguments may be in any order here. D equals 1, C equals 6, or C and then D, doesn't matter. Now, if there are default arguments, they must follow mandatory arguments. Have a look. We have a function definition. Now, here we have two default arguments with default values. These are optional parameters. Now, if we don't pass the default arguments, their default values will be used. So let's call this function with just two arguments, 1 and 2. We get 11 because C and D equal to 3 and 5. The default values were taken. If we do pass the default arguments, their default values will be overridden. So func 1, 2, 4, 8. Now C equals 4, D equals 8. We can use keyword arguments to reassign just some of the default arguments, skipping the others. Have a look. Now, if we want to pass a different value just for E, we can use the keyword argument like so. Func 1, 2, E equals 10. Or if we want to deliver different values for D and F only, we can do it like so. D equals 1, F equals 5. Without keyword arguments, if we wanted to pass different values for F, we would still have to repeat all the default values of the preceding default arguments, because these are positional arguments. So we would have to do it like so. Func 1, 2, and now, although we don't want to change these values, we still have to repeat them. 5, 3, 7, and then we can deliver the new value for F, like for example 10. If we wanted to pass a different value for D using just positional arguments, we would still have to repeat the default value of C because it precedes D. So if we want to change D, without changing C, we still have to use C here. Func 1, 2, 5, and for example 8 for D. This is why default and keyword arguments like cooperation so much. And now the harder part, the star and double star arguments. In function definitions, we use a single star to pack all the unmatched positional arguments in a tuple. The double star is used to pack all the unmatched keyword arguments in a dictionary. Here are two simple examples that demonstrate how they work. So first with positional arguments. Here we have a function which takes an arbitrary number of arguments and just prints them out. So let's call this function with 6 arguments. Func 1, 2, 3, 4, 5, 6. Here's the output. And now an example with keyword arguments. This function takes an arbitrary number of keyword arguments and also prints them out. Let's call this function func. Now, for example, A equals 1, B equals 2, C equals 3, D equals 4. And what we get is a dictionary. If we need both positional and keyword arguments in a function, then first come all the single positional arguments. Then we can use the star notation to pack all the remaining positional arguments in a tuple. And last come the keyword arguments packed in a dictionary using the double star notation. Have a look. So here we have a single positional argument, then all the unmatched positional arguments packed into a tuple, and then all the keyword arguments packed into a dictionary. And now let's call this function. We can do it like so. Func. Now here we need one positional argument that will be assigned to A. Let's take 4. Then we can have an arbitrary number of positional arguments that will be packed into a tuple. So for example, 5, 6, 7. I think 3 will do. And then we can have an arbitrary number of keyword arguments that will be packed into a dictionary. So for example, M equals 10, N equals 20, P equals 50, S equals 90. So here we have 4, but we can have any number. And now let's press enter, and this is what we get. Here we have the single positional argument, then we have the tuple into which these remaining positional arguments were packed, and then we have the dictionary to which all the keyword arguments were packed. When we use the star and double star notation in function calls, we unpack tuples or other iterables and dictionaries into individual positional and keyword arguments, respectively. The order is the same as in function definitions, so star precedes double star. Here are some examples. You have a definition of a function that takes 6 parameters, and let's call this function with 6 arguments. 1, 2, 3, 4, 5, 6. Okay, the function returns the sum of all the arguments. And now let's pass 2 positional arguments, 1 and 2, and then let's pass a tuple consisting of 4 elements, but these 4 elements must be unpacked into individual elements so that these individual elements can be assigned to these 4 parameters. So we need a star and the tuple 3, 4, 5, 6. So actually this function has 3 arguments, 1, 2, 3, but the last argument is unpacked because of this into 4 individual elements, and we'll have 6 elements altogether as required by the function. So it works too. And now let's call this function like so. Func. First, let's take a tuple of 2 elements and unpack it using a star. Star 1 and 2. Then let's take a dictionary consisting of 4 elements, and we also have to unpack it using a double star notation. Now, C 3, D 4, E 5, F 6. It also works because it unpacks these 2 elements and these 4 elements into individual elements and would have 6 altogether as required. And now let's call this function like so. Func. One positional argument, then a tuple of 3 elements, 2, 3, and 4, and then a dictionary of 2 elements, E 5, F 6. It also works. Things get even more interesting if we add keyword-only arguments to the lot. If you don't know what keyword-only arguments are, I have a video on that too, so feel free to watch it first. We know that keyword-only arguments must follow star arguments in the function definition. But if we also have double star arguments in the definition, then the keyword-only arguments must precede them. This means the keyword-only arguments must come between the star arguments and the double star arguments. Have a look. Here we have a function, and now here we have a star argument, a double star argument, and C is a keyword-only argument. It's between the star argument and the double star argument. And here's how we can use the function. Func. Now we have to pass one positional argument. So let's pass 4. Then we can pass an arbitrary number of positional arguments. They will be packed into a tuple. So let's pass 3, 5, 6, and 7. Then we need a keyword argument. So let's set it to 10. C equals 10. And then we can use an arbitrary number of keyword arguments. So let's use 4. For example, M equals 20, N equals 40, O equals 30, P equals 25. Doesn't matter. And this is what we get. The function just prints all the arguments. So here we have the first argument for the positional argument. Then we have a tuple consisting of 3 elements. This is the tuple into which these 3 positional arguments were packed. Then we get the keyword argument, C, and then we get a dictionary into which all the remaining keyword arguments were packed. We can skip the keyword-only argument in the function call if we assign a default value to it in the function definition. Have a look. Here, this is our keyword-only argument, and we assign the default value of 100 to it. And now we can call the function without this argument. So let's do it now. Func 4, this is the first positional argument. Then an arbitrary number of arguments, so let's pass 5, 6, and 7 again. Then we should pass C, but we can skip it because it's set to a default value. And then we can have all the remaining keyword arguments. So M equals 20, N equals 40, O equals 30, P equals 25, for example. And this is what we get. We still have C in the output because it is still there. And we can see the default value here. Now in function calls, we can use keyword-only arguments before or after star arguments. They can also follow the double star arguments. Have a look. Here we have a function, and here we have our keyword-only argument. Now, let's place our keyword-only argument between the star argument and the double star argument. This is how we've been doing it so far. So let's call this function like so. Func1. This is the mandatory positional argument. Then let's have a tuple of 3 elements which must be unpacked 2, 3, 4. Then let's use our keyword-only argument c equals 5. And then let's use a dictionary which must be unpacked 2 with 1 element. D set to 6. And this is what we get. 1, the tuple, our keyword-only argument, and the dictionary. Now let's call this function placing our keyword-only argument after the double star argument. So, func1, the tuple, then the dictionary, and only then our keyword-only argument. It still works. And now let's place our keyword-only argument before the star argument. So, func1, now our keyword-only argument, c equals 5. Now the tuple, and the dictionary. Works. What's interesting, our keyword-only argument can be included in the double star argument. Let's have a look. Func1, then the tuple, then the dictionary, and we can include our keyword-only argument here in the dictionary. And this will work too. Yeah, it does. Well, don't worry if these rules look overwhelming. In most scenarios, you don't need all the different types of arguments in one function. But from time to time, you can come across such functions. If you want to practice a bit, there will be a drill on function arguments in my next video, so stay tuned. Okay, that's it for this video. If you like it, a thumbs up would be great. Also, make sure to subscribe for future videos. If you want to leave a comment or ask a question, you're welcome to do so. Thanks for watching.